Welcome. This video is meant to show you the basic operation of a laser cutter, software requirements, operational guidelines, and what you can and can't do with the machine. Here we are at Hacker Lab, a hacker makerspace in Sacramento, California, and we're going to use a laser cutter here to demonstrate some of the basic concepts behind laser cutting. The first thing you want to keep in mind when using a laser cutter, and honestly any machine, is safety. We'll get to the fundamentals here in a moment, but I want to take a moment to speak to safety and respect. When you're using any machine, you want to have an appreciation for what it can do to you. This laser cutter uses a high-intensity beam to burn through various materials. Improper usage could result in damage to yourself through burns or to your eyes through looking at the beam without adequate protection. The second bit of safety you want to keep in mind is adequate ventilation. A lot of the materials you can cut using a laser cutter release noxious and/or carcinogenic fumes when burning. A proper ventilation system is a must when using this machine. Now, back to the machine. The laser cutter we're using today is a Morentek MT-L960 laser cutter. It is also worth mentioning that all laser cutters vary and have their own specifics in how they operate. We're going to hit the basics here, but be sure to be aware of the specifics of the machine that you are working with. Okay, enough of that. The laser cutter we have here is an 80-watt laser. You'll hear the term wattage a lot when dealing with laser cutters. Essentially, a higher wattage means a more powerful laser, which translates to the type of materials that you can cut and allowable thicknesses for those materials. It's a common question, so I'll answer it now. If you want to cut metal, you're looking in the neighborhood of a 300-watt laser, which is not this guy. The laser cutter cuts material using a high-intensity laser beam that burns through material placed on the laser bed, here. Parts of the laser you want to be familiar with are the air compressor, here, which generates air that is blown over the cutting area to reduce the risk of fire. I said reduce, not eliminate. We've already discussed ventilation, so let's also mention the water pump, which circulates water through the laser tube to cool the laser as it performs tasks. The most common materials we use on this laser cutter would be plywood, MDF, medium density fiberboard, and acrylic plastic. But by no means are we limited to those materials. You can cut paper, cardboard, felt and other fabrics, leather, and the list goes on. You want to be careful about the materials you use. Some materials release noxious gases when run on the laser cutter, and others, due to material properties, aren't well suited for laser cutting. The path that the laser cuts is determined by a user-generated software file that can be created in various ways. The type of file the laser cutter wants to see is often some type of two-dimensional vector graphic file. The most common formats I've seen used are .svg, .dxf, and .ai files, but others can be used as well. Programs you can use to generate those files are Adobe Illustrator, AutoCAD, and CorelDRAW. As those programs cost money, there are free and open source options available, which I am a huge fan of. The one I'm specifically going to mention and demonstrate is a program called Inkscape. Inkscape is an open source vector graphics program, similar in many ways to Adobe Illustrator. It is often the starting point I recommend to people wishing to get started creating designs for the laser cutter. If you're more technical minded or have a CAD background, I'd recommend DraftSight or LibreCAD. These programs give you a bit more specific positional control of your files, and depending on whether you're more artistic or technical, one or the other might be a more comfortable space in which for you to work. So we'll use Inkscape as the example here. As mentioned before, the laser cutter uses information from the vector file to determine the path, and it is in the program Inkscape that we will create those paths. If you've ever used Microsoft Paint or a similar program, one of the first things you may notice is how I am drawing lines and other shapes to create my object, as opposed to depositing color on the canvas with some sort of digital paintbrush. I create these paths by selecting points in the digital space, and it is these points that determine how the laser will move across my material. I could spend an entire video talking about things to keep in mind when creating files for laser cutting, but I'll highlight a couple here. First off, keep in mind that each line, shape, or object you create is an independent entity. If you overlap lines, possibly by copying images to create a pattern, or hide the lines by changing color settings, the laser cutter will most often pick these entities up and run these paths as well, which will most often give you undesired results. So now that we've seen the machine run, let's talk about some of the advantages and disadvantages to the manufacturing method. One big advantage to laser cutting is the relative low cost of manufacture, not counting labor, of course. Plywood and MDF are readily available and not terribly expensive. Other materials such as acrylic can get a little more expensive depending on the source, but still not too bad for one who wants to work on a side project or are looking for a low-cost method to prototype an idea. Another non-obvious advantage is the flexibility of what you can create with the machine. Puzzle, with a little ingenuity and mental flexibility, you can use the laser cutter to create some stunning 3D creations. Additionally, the laser beam is rather accurate, meaning that if you do your work beforehand, you can create designs that rely on press or interference fits. Disadvantages to laser cutting. Oftentimes, due to the power of the laser, you are limited with the thickness of the material you can cut, which can limit the scale or structural strength of your end product. This can be counteracted by using cross members and the like, but there is still a limitation. Another disadvantage is the burning or other marring of your workpiece. As you are burning through the material, there's a possibility for charring or less than desirable finish on your piece. This can be counteracted a number of ways. With wood, a little sanding can help with burn marks. With acrylic, there are cleaners and other solvents. It is also possible to minimize this with proper manipulation of laser power and speed settings. It is possible to cut paper, cardboard, and fabrics without char marks, if you're willing to put in the time to find the proper settings. One thing that I left out, while laser cutters often take 2D vector data, they can also use 2D raster image data as well. What that means, it's possible to engrave and emboss pictures using the machine as well. So you can take a photo you like and do a cool emboss. I'm Alan Ware with AMW Design, and I want to thank you all for watching this video. I also want to thank Hacker Lab for making the laser cutter available, and the Sierra College Center for Competitive and Advanced Technologies for giving me the opportunity to make this video. Thank you.